Hi everyone, Leo here, and what if I told you that the most accurate amp profiling technology on the planet is going to get a major upgrade, being still completely free? Today we are doing a technical deep dive into both the original NAM and the new upcoming A2 architecture. I'll explain how NAM works, focusing on what are the main differences between the original version and the new A2, and why it matters for all of us. Let's start. For those who don't know, Neural Amp Modeler, NAM, is a free open source technology created by Steve Atkinson that uses machine learning to create digital models of real amplifiers, pedal and other gear. Unlike traditional amp sims that use white box circuit modeling, where engineers mathematically simulate resistors, capacitors, tubes, etc., NAM takes a black box approach. It treats your amp as a mystery box and simply learns. We send a special training signal through our amp, record what comes out, and then a neural network learns to replicate the exact behavior. Furthermore, there is a massive community on Tone 3000 with over 200,000 captures that we can download and use right now. Everything from vintage Fender Twins to modern high-gain monsters, classic Vox AC30 to boutique pedals. It's all there. Now let's get into the technical details. As far as I understood, NAM at its core uses something called dilated casual convolutions. Casual means the network only looks at past audio samples to predict the current output. Dilated means the network skips over samples at increasing intervals. The dilation patterns, typically 1, 2, 4, 8, etc., creates what's called the receptive field. This is how far back in time the network can see when making a prediction. The standard NAM architecture uses 2 stacks of 10 convolution layers each. If I'm not wrong, this gives the network a receptive field of over 4,000 samples. At 48 kHz, that's roughly 83 milliseconds of audio history. If I'm not wrong, please let me know in the comment section. And this is enough to capture the complex time-dependent behavior of tube amplifiers. So now we know the network's temporal structure. 2 stacks by 10 layers, with dilation controlling how far back it can see. But there's another dimension to consider. How much can each layer learn? This is determined by 2 parameters. Channels. More channels means the network can detect more different features simultaneously, like having 16 microphones instead of 1, each picking up different aspects of the sound. And the second is the kernel size, that determines how many samples each filter looks at in one operation. A kernel size of 3 means each calculation considers 3 consecutive samples at a time. The A1 standard architectures uses 16 channels for the first layer and 8 for the second one, with a kernel size of 3. This, plus other parameters that would be too complex to explain here, leads us to approximately 13,800 parameters, that is the actual dimension of our profile. This is exactly why NAM offers different architecture tiers. In fact, the A1 architecture comes in 4 flavors. The A1 standard with 2 stacks of layers, 16 channels, kernel size 3 and 13,800 parameters, dilation pattern 1, 2, 4, 8, etc. And this gives us the best accuracy and the highest CPU usage. Then we have the A1 Lite with reduced channel count, good for simpler amp models, lower CPU usage. Then we have the A1 Feeder, which is a minimal architecture, perfect for clean or simple pedals. And then we have the A1 Nano that needs about half the CPU of Feeder and is designed for extremely constrained embedded hardware. A1 standard has become the de facto industry standard. High-end hardware like the Anagram was designed to run the standard A1 architecture. But budget devices often can't handle it. They use NAM to X conversion approaches that convert NAM files to lighter proprietary formats, potentially compromising accuracy. Now, with all we have said previously, we are, in my opinion, able to understand why the A2 architecture is important. And let me break down the technical improvements with A2. First, lower CPU requirements. The A1 standards 13,800 parameters require significant processing power, where A2 will be designed with specific industry CPU budgets in mind, informed by real hardware constraints from manufacturers. Improvement 2. Slimmable NAM. NAM will be slimmable. Slimmable NAM allows a single train model to operate at multiple widths, meaning the number of channels in each neural network layer can scale dynamically. Think of it like this. Imagine we have a highway with 16 lanes of channels. At full width, all 16 lanes are active and we have maximum throughput, maximum quality. But if we are on a smaller road, having a limited CPU, the model can automatically reduce to 8 lanes or 4 lanes, using fewer computational resources while maintaining as much quality as possible. In the NAM plugin, this is gonna be as a simple slider. Slide it to the right for the maximum quality, slide it to the left for our battery-powered mobile device. I guess that here the innovation is that this is trained from the ground up. Previous approaches used pruning, training a big model then cutting it down, which loses quality. Slimmable NAM trains a family of weights that share structure across multiple width configurations, so each size is optimized, not just a cut-down version of the full model. At least this is what I guess. Even if, of course, slimming the network, the quality decreases. Steve Atkinson's research paper, presented at the NEUR IPS 2025, shows slimmable NAM models from an efficient Pareto front, meaning at each computational budget you are getting the best possible accuracy. Another improvement could be done with A2 that is related to the use of a new activation function, specifically optimized for audio processing. Recent research has shown that activation function choice significantly impacts both accuracy and aliasing artifacts. I don't know if A2 will go in that direction, but who knows, maybe we can have some improvements also in that area. I noticed in this website that there are many activation functions tested, therefore I guess that something may be happening here. Let's now put A1 and A2 head to head for you to easily understand the main differences. The architecture is fixed in the A1, where in A2 is slimmable. We have 13,800 parameters in the A1, where they are adjustable in the A2 with channels of variable width, where in the A1 they are fixed. The activation function may be different in A2, and I have great hope here. The CPU scaling is discrete with 4 tiers in the A1, where in the A2 we have a slider. The file format and the sample rate should be unchanged, where the hardware compatibility should be much higher for the A2. By the way, another key point is that A2 isn't replacing A1. When A2 launches, Tone 3000 will retain all captures in the library to the new architecture. Both A1 and A2 version will remain available. So, for guitarists and hobbyists, our workflow doesn't change. Current captures keep working. A2 captures will be a drop-in replacement with the same NAM file format, just potentially better sounding and lighter on our CPU. For hardware manufacturers, this is huge. A2 is being developed with direct industry input on DSP constraints, memory limitations and latency budgets. And if you are an hardware manufacturer, you can also contact Tone 3000 to participate in beta testing and influence the final specification. For capture creators, you won't need to recapture your gear. Tone 3000 will automatically retain existing captures to A2. Your original recordings remain valid. For developers, The full A2 specification, training code and DSP implementation will be open source. You'll be able to integrate slimmable NAM into your own products. Here's the roadmap. Now through early February 2026, industry requirements gathering. February 2026, beta testing of preliminary A2 models. March 2026, full A2 launch. So there you have it, a deep dive into NAM A1 versus A2. The A2 brings a slimmable architecture that dynamically adjusts computational load, maybe improved activation functions for better accuracy and reduced aliasing, and industry-informed design for broader hardware compatibility. NAM has already proven itself with super good profiles. A2 is taking that foundation and making it more efficient and more flexible. This is very important because the more hardware is compatible with NAM with good quality, and the more NAM become widely available. I'll definitely be doing a follow-up video when A2 actually drops, with real audio comparisons, null tests, etc. So subscribe if you want to see that. And now please drop a comment below. What do you think about A2? Isn't the slimmable architecture the real bump in NAM adoption over available hardware that we were waiting for? Could the utilization of new activation improve NAM performances, also reducing aliasing? Please let me know in the comment section below. So as you can imagine, this video took a lot of time, so please subscribe and ring the bell, as it would really help me to create more videos like this. Thanks for watching and see you soon. Bye bye.